Now, the third subtopic that we take up here is types of forces. Now, force can be applied by contact, or it can also be applied at some distance without even touching it. Now, what are these kinds of forces? We are now going to study that. Contact forces, whenever two objects are placed in contact with each other, they'll apply a force. So, whenever there is an application of force that involves contact between two objects, it is termed or it is classified as a contact force. When the application of force does not involve any contact between the objects, it is said to be a non-contact force. Now, we will take up a few examples of contact and non-contact forces. Now, what are these? You can see in the image that contact forces, examples of contact forces, applied force. Now, what is applied force? Whenever you have an object and you push it or you pull it, you apply a force. Now, this kind of a force is called applied force. So, whenever you are applying a force, you are essentially touching it and applying it. So, in the example that we discussed a few minutes back, where the boy was pushing a pram, what was he doing? It was a contact force, because he was applying a force on that particular pram, causing it to move. So, that was an example of an applied force. So, any applied force will have contact of the objects. The object that is applying the force will be in contact with the object on which the force is getting applied. So, that's an example of contact force. The other example is of spring force. Now, what is spring force? If you take a spring and keep it in a non-distended form, if you keep it in a normal form, it's not going to cause anything. It will just lie wherever it is kept. But if you press the string and if you put a block or a pen cap on the two sides of the compressed spring and you release the spring, what will happen? The spring is going to shoot out, and the pens are going to flow, they are going to move out. So, where is the force coming in? When you compress the spring, there is an internal energy that's stored in the spring, and when you release it, this energy gets converted into the force. So, there is a force, a spring force that acts on the two objects that are kept at the ends of the spring, and that spring force causes the objects to move. So, here also the objects need to be in contact with the spring. For example, if you compress the spring here and you keep the object here, if it just distends, nothing will happen to the object that is not in contact with the spring. So, for the application of spring force, you need the object to be in contact with the spring. So, a spring force would also be an example of contact forces. Now, third example is the drag force. When you jump from a parachute, what happens? When you jump from the parachute, you are in contact with the air, and what does the air do? It pushes you. There is a resistance from the air that is applied upwards on you. When you are going down, the air resistance acts upwards on you, and that is called the air drag. Now, in that case, your body is in contact with the air. Some people might say that there is no contact because you are experiencing that force, but you can't see anything, right? But it's not necessary that the contact force has to be visible. The air is invisible, so it is always in contact with you. So, it is a contact force. The next example is frictional force. When you walk on a road which is not smooth, what happens? You experience a force. If you try to run on a smooth road, or if you try to drive on a smooth road, vis-a-vis you drive on a very rough road, what will happen? Driving on a rough road is going to take you more time, and driving on a smooth road would probably take you lesser time. Why? Because there is a less frictional force that acts on the tires of the car in case of a smooth road. So, whenever there is a body in contact with the surface, it is going to experience contact force. It is going to experience that frictional force that will try to pull it backwards if it is moving forward. So, frictional forces also involve contact between two objects, and hence they are also contact forces. The last example that we see here is the normal force. And what do you see here? You see an object is kept on a table. Now, the contact force acts perpendicular to the surface of contact. So, in here what you see is there is an object and there is a table. So, the table would apply an upward force that is perpendicular to itself, and the block is going to apply a force that is going to act downwards. So, if you take the block, the normal force acting on it would be upwards, as you can see in the figure. The table will apply a normal force on the block, which will be in upward direction, and the block will apply a downward normal force on the table. So, this is what is shown in the figure with the arrows. The arrow that is acting upwards on the block, it signifies the contact, the normal contact force that the table applies on the block. So these are some examples of contact forces. Now what are non-contact forces? What do you see here? There are a few examples of non-contact forces. The first one is magnetic force. You must have experienced, you might have played as well. You take a bar magnet and you keep iron nails and you keep them at a distance. The iron nails are going to get attracted towards the bar magnet. Now there is no contact involved, but there is some kind of a force that's pulling these nails towards the magnet. Now this invisible non-contact force is magnetic force here. Similar is the case in case of charges. So when you have a positive charge and a negative charge, they will attract each other. So that is the case of electric force, as you can see in the second example. And the third example is of gravitational force. If I take you up on a building and if I drop you, you're not going to float in the air, right? You're going to fall down come what may. If nothing holds you up, you're going to fall down. And what pulls you down? It's the Earth's gravitational force, right? So when you're up in the sky, the Earth is not in contact with you, but it is pulling you towards it. So there is a force called gravitational force that acts between any two objects kept at any separation. The magnitude might vary, but the gravitational force would always act between two objects. So when you drop something from the top of a building, it keeps falling down, and it keeps falling down because the application of a non-contact gravitational force that acts on the object from the Earth. So that is a gravitational force that acts. So we have now seen what contact and non-contact forces are, and what are the different types of force that you can classify as contact or a non-contact force. So probably you should take an activity from the book, you should read through it and try to identify the cases that are given there about contact and non-contact forces. Now let's move to the next subtopic.